VP of Research at NetSpy, who will delve into the nuanced landscape of managed identities across multiple Azure services to demonstrate how attackers exploit access to services with these identities for priv-esc and lateral movement. The title of Carl's talk is Identity Theft is Not a Joke, Azure. Please give a warm welcome to Carl.
Thank you. All right, we're going to try and keep this on the mic stand here, and we'll get started. So thank you everybody for coming out to the talk today. We got a nice full room here. Sorry for the folks in the back. If you can't hear me all that well, I'm going to try to get real close to the mic so you can hear it. But let's get started. So I had a quick brief intro here, but Carl Fossen, done lots of stuff in the cloud space, been here before, presented last couple of years here. But if you were at last year's talk with Thomas Elling, we did the Funko Pop tool attacking function apps. And also the creator of Microburst wrote a book, Pen Testing Azure for Ethical Hackers, with David Occhiotti a few years ago. You can go find that out at the QR code over here. For those that are not familiar with the US version of The Office, there's a scene in that with Dwight and all this other stuff. That's where the talk title comes from. So before we get into the actual, I guess, meat of the presentation here, let's talk about some previous research in the space. Pick this up. So we've got a number of different folks that have done a lot of different research in this space, from how to get tokens to how to get certificates to just all sorts of different attacks against managed identities. For folks that are watching this after the fact on a recording, go ahead and check out those slides. We've got links in the slides for all of those different blog posts there. But a lot of this research is based off of that research. So we're going to summarize and highlight some of this research, but please go ahead and check out all of those links at some point. I'll have the slides up on Twitter, LinkedIn, a bunch of other sources as well. So go check those out over there. So a quick overview of today's agenda. We're going to explain what managed identities are. I guess we probably have some folks here that don't know what managed identities are in Azure, so we'll give a quick overview of what those are. And then per service that we can attack within Azure, we're going to go over different attacks that we can do. There's a lot of services that use managed identities, but a lot of them are not really vulnerable to certain attacks. So we're going to skip over some of those and really focus on ones that we can do actual attacks against. We will finish that with deployment scripts. It happens to be one of those resource types that we can attack. And then we'll talk about where we can find managed identity certificates, which is part of the authentication. We'll explain that in a little bit. And wrap things up with how we can use those tokens and certificates that we either generate from the services or steal from the services to authenticate and do other things in Azure. So what are managed identities? Managed identities are Azure's way of authenticating as a resource to an Entra ID tenant. So an Entra ID tenant is your source of truth for anything identity when it comes to Azure. As a way to authenticate specific resources in an Azure subscription to an Entra ID tenant, we have managed identities. This is a service that exists to allow resources to authenticate and access different things within Azure. So our example here is we've got a virtual machine that needs to read a secret from a key vault. Very common scenario. We would use a managed identity, assign that to the virtual machine, generate a token against the IMDS, a similar concept for lots of other cloud providers that are out there. We'll use that token with the REST APIs to then query the key vault. So pretty simple process. Very, very common to see managed identities assigned to different resources in Azure, and this exact process, we see it all the time. This does eliminate the need for stored credentials on the specific resource. If anybody's familiar with automation accounts, they used to have run as accounts, which would have service principals that were attached to them, and those credentials were stored in the service. They've since sunset that, and that's all gone now, and have moved to managed identities. What you get with managed identities is just a token and temporary access to that point. So it's really just a temporary access token instead of permanent credentials, which is much more secure. The two different types of managed identities are system assigned and user assigned. So system assigned are tied to a specific resource. So virtual machine 1, that has a system assigned managed identity. That can only be used on virtual machine 1. If you have a user-assigned managed identity, that's a subscription-level resource, and that subscription-level resource can be shared against multiple different resources. So if you have the ability to assign the managed identity, That user-assigned managed identity can be assigned to multiple different resources. So if you've got 5 different virtual machines that all need to access the same key vault, you can use a user-assigned managed identity to access that key vault. You only have to set one access policy on it, and you can assign the user-assigned managed identity across multiples and just make it easier to scale and do all of that. That being said, user-assigned managed identities we can abuse. We'll talk about that in deployment scripts. Because we can assign them to multiple things, we can just kind of assume them at some point. And as I mentioned before, these are supported by a lot of different services. We're not going to talk about all of them. We're primarily just going to focus on the ones that you can actually exploit to get tokens out of. But managed identities are used pretty much anywhere. The underlying mechanism for the credentials for the managed identity is what's called a service principal. That consists of an app registration as well as an enterprise application. They're not super visible in the Azure portal. In order to dig into the specifics for the service principal, you have to hit up some of the APIs or some of the PowerShell commandlets. I've got an example here for the get AZ-AD service principal credential here for a managed identity. And it lists out the certificates that are associated with it. The service principal has a certificate that is used for authentication. We're going to talk about how we can get access to those in a couple of situations. But users are never really supposed to get access to those semi-permanent credentials. These are supposed to be abstracted away and put off into the token systems that are out there. So when you go out to get a token, that token service is going to use the credential to then authenticate to Enter ID, get you a temporary token. All you ever see is the token. You never see that certificate unless it's one of these situations we'll talk about at the end. For the token services, most of what you're going to see is kind of a metadata service, IMDS kind of situation, a 169.254 address. You're probably very familiar with those from other cloud providers that are out there. Very simple web request. For some of the other ones that we call more sidecar tokens, Function Apps is a good example of that. Those are local services that run in the container environment, and instead of a 169.254 address, it's a 127 or local host kind of address. They actually work pretty much the exact same way. It's just an HTTP request, you get a token back. They typically require headers. We're going to talk about each different service here and specify some of those headers, but we'll get into that in a minute. When you generate a token, you're generating a token for a specific scope. So we reach out to the IMDS, we say, hey, we want a management token, or hey, we want to go talk to a key vault. Those are the different scopes that we have listed out here. There's a whole bunch of different scopes that are out there, but the 3 primary ones that we see are management, graph, vault. That's about it. In terms of authenticating it as a managed identity, you can get a token. We can use those tokens with PowerShell. For the PowerShell modules, you can kind of feed those in as tokens there. Alternatively, if you're on, say, a virtual machine that has a managed identity assigned to it, you've got PowerShell or the CLI available, you can actually just log in with the identity flag, and that will talk to the local service, IMDS, or whatever it is, and authenticate you as that local managed identity. So, something to think about when you get on a VM or anything like that and want to pivot to the managed identity. If AZ PowerShell or the CLI is available there, that might be useful. So let's get into the individual services here. We'll start with virtual machines, but before we get into that, I'll explain for each one of these kind of initial access methods, how do you get into this service, because that may not be totally clear all the time, and how do we generate tokens from it. Additionally, we'll include some tooling options. We're not going to go through every little piece of every slide here. We'll use this as reference. If you want to go back to the slides later, you'll have commands and stuff available to you there, but just know that it'll be available later. And for each of the examples that we have here, we are going to focus on system-assigned managed identities. In cases where it's a user-assigned managed identity, a lot of the times you have to specify the object ID of the user-assigned managed identity that you want to get the token for. It can kind of throw people off sometimes because they'll see maybe in the portal like, oh, hey, this has a managed identity, but I'm not getting the right token for it, or maybe it's got user-assigned and system-assigned. It can get real complicated real quick. We're just going to keep it simple for all of our examples and just have it for system-assigned managed identities. So I know the text is going to be really tiny for the folks in back here, so I'll try to speak to the slides as best I can. But the first one that we're going to cover is virtual machines. Now this is inclusive of virtual machine scale sets. These are basically scalable versions of virtual machines. But as an attacker, we would want to get initial command execution on the virtual machine. This could be command injection, authorized Azure credentials that have the ability to do things like run command, or have the ability to, I guess, add extensions. There's a number of different ways that we can get commands running with Azure credentials. And finally, authenticated access. If you just have RDP or SSH access to a virtual machine, that's kind of your initial entry point here. With virtual machines, we want to make a request to that 169.254 IMDS endpoint, specify API version, specific resource that we want to scope to. So in our case, we've got a management token example, and that's going to get us a management token back. One thing to highlight here that I think is actually a really nice a nice benefit for Azure virtual machines for the IMDS is that they require this metadata true header. And what this does is it actually helps prevent a lot of the server-side request forgery or SSRF vulnerabilities. We've seen them with other cloud providers in the past where somebody gets the server to make a request out to that IMDS endpoint, then gets token or temporary credentials back from that. Because it requires a header with a lot of SSRFs, you don't really have control over that header that's going out in that HTTP request. So you can't say, hey, include that metadata true header, and that actually blocks a lot of those SSRF attacks. Really ends up requiring more of command injection kind of situation. So that's a nice benefit there. In terms of automated tooling for microbursts, we've got a couple of different commandlets here that allow us to run commands on virtual machines at scale. So if you've got multiple managed identities that you want to gather tokens for, pretty easy to just throw in that web request and then just kind of run that at scale. Next up, we have app services. This is also inclusive of function apps. If anybody saw our talk last year at the Cloud Village, we were talking about function apps there. And kind of similar situation. In order to get initial access here for app services, we need some form of command injection. SSRF isn't really going to work for us here. App services is an application hosting service, so you're hosting web applications or APIs via functions. So command injection, you're going to have have some kind of control over those headers again. Alternatively, if you have access to, say, the Azure portal via the console or the SSH menu, there's also the alternative management within Kudu. It's the SCM interface, is usually what it's referred to. But each of those options allow you to run commands directly in the app services or function app. And the last option that we'll call out here is the function app overwrite. This is what we talked about last year at the Cloud Village. But if you have the ability to overwrite files for the function app, you can actually entice it to give you tokens back. I'll just refer back to last year's talk if you want more details on that one. But this one also requires a header. Depending on the type of app services app, you either need a secret or X identity header, and it's used exactly like that metadata true one, but this one's a little bit different. It's a secret that's tied to your specific instance on the container environment. We'll talk about something with automation accounts, which is why this is really important, but just think of it as a secret identifier that you have in the container, and it works for you to get those tokens. So you either hit up the MSI endpoint or the identity endpoint, and that will get you a token back. Very simple process. Oh, and I'll call out tooling options here real quick. Within microbursts, we do have two different options to run commands on App Services app. We have a relatively new one that's the App Services Kudu debug, which emulates the connections that you see up on the debug console up at the top there. And then the AZ App Services CMD, which runs commands directly through those Kudu APIs. And we'll also call out Funko Pop, which is the tool that we released last year. Next up, we have Azure Container Registries, or ACRs, as I'll refer to them going forward. So ACRs are a way of managing containers or a container repository up in Azure. And they allow you to execute tasks in the ACR service. I called out Andy's research on here before, but Andy Robbins has some really good research that initially pushed me in this direction. I was trying to replicate the steps in his research and ended up just kind of rewriting it so I could just write my own tool that automates the whole process. That's the tooling option here for the Invoke AZ ACR token generator. But the general concept is that ACRs allow you to attach a managed identity to the ACR tasks so that when you run a task to, say, pull in a container, modify some files, and then push the container back up, you can do so with a managed identity. You might want to use a managed identity to, say, access a storage account or access other key vaults or anything like that, and integrate those into your container builds. And that's all managed by some task YAML here. So you create the task, you push out the YAML for it, and the steps are really, really simple. You basically say run a command to log in as the identity, and it's okay if there's no subscriptions, and then just get an access token and output it. That's all it does. What happens is you output it into the little screen here, and once you've run the task, copied out your token, you're all good to go. And at that point, you want to remove and clean up the task, because anybody that has reader permissions on that ACR could potentially read out the token that you just dumped out to the task output, so be careful with that. We are particularly careful with that in the microburst tooling option, because we try to make sure that it's only temporarily exposed. We want to make sure that we're not exposing tokens out to the rest of the world. So we just very briefly expose that, delete it as soon as we can. Next up, we have automation accounts. Automation accounts are near and dear to my heart. I've spent countless days, weeks, months waiting for automation account jobs to finish sometimes. It's something I've done a lot of research in, so big fan of automation accounts. But for your initial access to an automation account, and I should have highlighted for ACR, your best bet here is getting access to Azure credentials. You might get ACR management or admin credentials. I forgot to mention that earlier. If you have the ability to modify tasks in ACRs, you can do this attack. So similarly, for automation accounts, if you have Azure credentials that have some form of right or contributor on the automation account, you will have the ability to write, edit, create, and execute any automation account runbooks. So runbooks are a way of running serverless code up in Azure. Oftentimes, the automation accounts are relatively well provisioned from a permissions perspective. It used to be that the run as accounts that were associated with it would have contributor on the entire subscription. So that was a great pivot point if you got control over one of those, because then you'd have full contributor over the full subscription. But nowadays with managed identities, a lot of folks have carried that over to just replace the run as accounts. So oftentimes we'll see full subscription contributor or higher permissions, because a lot of times automation accounts are being used to do things in other subscriptions or kind of at the tenant level. So there's some good permissions that hang out in automation accounts. Either way, we want to create a runbook that authenticates with the attached managed identity. We can output the token into the task output, much like we did for ACRs. And we can either run this in the test pane or run it as a separate job on its own. I like running in the test pane because then we don't have to publish it. I will recommend, if you want to be a little bit more safe about doing this method, once you generate your token and output it in the test pane, go back to your runbook, delete the output that you had before, and rerun it, because anybody with reader permissions can go ahead and read previous test pane executions, which then you're exposing credentials out that way. We don't want to do that. Alternatively, you could exfiltrate tokens via HTTP, DNS, whatever method you like to exfil data out of. But either way, we generate our token, get it out of there, and then we're good to go. I will say that although automation accounts typically can use the PowerShell modules to authenticate, I'd recommend using local HTTP requests against their sidecar service to get your tokens back. I've had it where PowerShell modules kind of fail and you can't get the tokens out, so you just end up having to rely on the metadata service to get those back. I just recommend taking that route. As I previously mentioned, the X identity header here, there was the auto warp vulnerability that was, I want to say, 3 years ago at this point. But I have that listed in our resources here. Definitely go check that one out. When the managed identity service got pushed out to automation accounts initially, the X identity header was not required. the service that grants out those tokens listens on a high number port in the containerized environment, and there was not proper separation between the different containers. So what the researchers here found out was that you could enumerate other high number ports, make a request out to that sidecar service for other tenants that were being hosted in that same containerized environment, and get managed identity tokens for other tenants. So huge exposure, like really cool cross-tenant vuln. Definitely look that one up. That one was fun. Last little bit here, we'll note the automation account hybrid workers are a way to get out of that containerized environment. Let's say that you've got large files that you want to work with. You can enroll a virtual machine as a hybrid worker for automation accounts. They have their own little system for how they get jobs to run and how they do the runbooks, all that kind of stuff. It's called the Job Runtime Data Service, JRDS. But if you have access to that virtual machine, you can actually get the managed identity token for the automation account by querying the JRDS from the hybrid worker. We had a blog post that came out 6 months ago, roughly, that explains part of that process as well. If anybody's familiar with GetAZ passwords, we do have the option to generate managed identity tokens for automation accounts out of that, along with dumping passwords for pretty much anything else that's in Azure at that point. All right, next up we've got logic apps. This is kind of one of the last services that we'll cover here. And for logic apps, this is kind of a low-code, no-code solution within Azure to plug together a bunch of different connections. In our case, we've got an HTTP connector to automate a lot of actions in the Azure platform. I'm a big fan of this. You can make a single HTTP request out to something, then it goes through a whole workflow. You don't really have to write any code. You can plug in a bunch of things together, and people love to put passwords into these. We find all sorts of cleartext credentials, tokens, all sorts of good stuff here. But with access to a logic app with the correct credentials to modify a logic app, you can either modify an existing app that has a managed identity attached to it, or potentially create a new app and attach a user-assigned managed identity if you want to go that route. The next thing that we're going to cover is going to show a much simpler way to get access to a user-assigned managed identity, but we'll save that for a minute. And with the logic app, all you need to do is create a new HTTP request function, so an outbound HTTP request, and then you set your authentication type to managed identity, choose the managed identity you want to use, and then select your audience, so vault, management, et cetera, and then you just point it at whatever URL you want to. So Burp Collaborator server, whatever HTTP server you like to use, and you just sit there and listen, you run your logic app, and even though you're not talking out to a Microsoft endpoint, it goes, oh, hey, I got a managed identity token. Here you go. And you just capture that on your end. So it's kind of a handy way to collect those from managed identities. If you want to be persistent, you can add parallel paths in logic apps so that you could add a secondary path that gets processed. You just add that HTTP request so that every time that logic app runs, you get pinged back with a token. Kind of a nice persistent method there. Alternatively, with logic apps, there's some great research. I think I have it in the list. I'm not sure. I don't remember. The researchers who wrote it are here. So, but anyways, you have the option to backdoor logic apps that are on the standard plan. There's two different options, standard or consumption. And if you're on the standard plan of logic app, which is kind of the more enterprise grade, that's backed up by a function app, and that exists in the same subscription. You can actually take over that function app if you have permissions to the storage account that supports it. And you can use our Funko Pop tool, or you can kind of manually go through this process as well to effectively inject a Node.js payload into the function app and make that run and get tokens out that way. So it's kind of an extension to what we released last year. Thanks to the new research that came out, I had motivation to finally get the Node.js payload working. So yeah. So the last of the kind of services that we're going to talk about is deployment scripts. And deployment scripts is a little bit different because it's not really a service, but it kind of is. So deployment scripts are a way to run code or scripts in the context of a resource deployment. Anybody familiar with ARM or Bicep? Okay, I see a few hands up here. ARM and Bicep are templated languages that you can use to deploy Azure resources. And within those templates, you can actually create a deployment script. It's a resource type. You can navigate to it in the portal. And that resource script can contain any code that you want to run. So the most kind of common things that I see it used for is to configure virtual machines post-deployment, add extensions to them, things like that. Well, from our perspective, we can attach a managed identity to that deployment script. It has to be a user-assigned managed identity. And what I really like about this one is that if you've got kind of a free-floating user-assigned managed identity that has permissions that you want, and you have the ability to assign it, you can just tell the script, hey, I want this specific user-assigned managed identity, and I need a token for this scope for it. So it's actually really, really nice. We'll explain the tool here in just a second, but you just target the managed identity that you want to go after, and we also list out these specific permissions if you're able to read those, so kind of handy. But at the end of it, the script itself cleans up the storage account and container instance that's associated with the deployment script, and it just automates the whole thing. I have Rozier's name here. He did the original research on this with Project Meow, so definitely go check that out. But the script I'm talking about is invoke AZ UA deployment script. Might be a fun one to make use of if you've got some form of contributor or some form of write access or assign access on a user-assigned managed identity. But we're not going to linger on this one for super long here. All right, moving on to the fun stuff. Finding certificates for managed identities. Now, this is starting to kind of blur into some new research that was just released this week here. We'll talk about that on the next slide, and some old research that we weren't able to close out last year. We actually had this ticket in process during the talk last year. I was really hoping to get it cleared out before the talk so we could talk about this last year. But for anybody who was there last year, you might remember with the function apps, we were able to access a configuration for how you spin up function app container. So if you have command execution on a function app container, you have the ability to read the environmental variables, which include a start context SAS URI. Basically, it's the configuration for the container when it gets started up, and it tells it how to run the function app itself. That is encrypted with an encryption key and initialization vector with AES, and we have all of the components we need to decrypt that on the container because the container needs to decrypt that. And what we could previously access would be storage account connection strings, source code files, the function app secrets themselves. Those all still exist in that context. What we weren't able to talk about last year was the MSI specialization payload, which was also another part of that config. Now, this is specific for the Linux containers. This doesn't apply to the Windows containers for function apps. But with those Linux containers, what we found is that in the JSON that we were able to decrypt, you actually had the base 64 representation of the PFX files for the managed identities that were associated with the function app. So if the function app had any managed identities associated with it, their credentials, the PFX files or the certificates to authenticate as a managed identity, were being sent through that encrypted context. Now that's being pushed off to a different sidecar service where the key lives off somewhere else now, so that's all been fixed. But that one was kind of fun because we just put the base 64 file and then we can authenticate as the managed identity whenever, wherever we want to. And we'll talk about some specifics around why that's a little complicated in just a minute. So with that in the back of our minds, we started looking at other services in Azure that might have managed identity certificates floating around. One of these is the Arc service. This one's been kind of on the radar for a while. I've wanted to poke at it for quite a long time. It's been in the research queue. And Arc is a way to enroll non-Azure systems into your Azure environment. So let's say you've got AWS EC2 instances that you want to somewhat manage through Azure. You can enroll it in Arc and then give it access to different things. So when you enroll one of these systems into Arc, it enables things like VM extensions. It has a system assigned managed identity tied to it, which you can then give permissions to. And you can then use the systems as hybrid workers for automation accounts. It's really just a way to bridge your Azure cloud with other either on-prem or other clouds. It's a really convenient service. Where I was really curious is, okay, well, system-assigned managed identity. Where are they storing, authentication for this? Are they doing some kind of IMDS that's hosted on the cloud? What's going on? Turns out they just give you the managed identity certificates directly on the file system. Now, you have to be a local administrator to get access to those certificates themselves, but for the Windows systems, it's just a file called mycert.cer. For Linux, it's also called mycert. They just live off the operating system files. Now, while neither of them are actually specified as a PFX file, they're both PFX files. So super easy. You can just cat them out as base64 and get access to them. What this allows you to do is exfiltrate the certificate from those systems and then authenticate as the managed identity off of the system. Depending on what permissions are assigned to that managed identity, this could be used for lateral movement, privilege escalation. As I said, this is used to bridge kind of cloud and on-prem. So let's say you escalate in an on-prem environment, you get access to one of these ARC-enabled systems. You now have a certificate that you can then authenticate to the Entra ID tenant and potentially get access to things like key vault, storage accounts, other things that they might assign permissions to for that managed identity. This also allows for much more persistent access as the managed identity. Hypothetically, if you have command execution on the ARC system, you can access its local IMDS and get tokens for that. But those tokens are only good for, I think, an hour max. I think it depends on the service and how long they issue tokens for. I've seen it 5 minutes, I've seen it longer. But anyways, this allows you to persist for a couple of months potentially with those credentials. And I don't think I have it on here, but one of the other things is that when you authenticate with that managed identity, Microsoft assumes that you're never going to authenticate as the managed identity off of the resource. So they don't do great logging on it. You can authenticate with those certificates off of the resource itself, and you don't have source IPs or anything like that. It's not great for logging and detection on that. So definitely something to keep in mind. We created a tool to automate the collection of those certificates. We won't spend a ton of time on this because we're kind of running out of time here. But the Get AZ ARC certificates is now in microburst. You can go ahead and play around with that. You basically select the ARC systems that you want to attack. It cats out the cert files itself, saves them locally, and then generates an authenticate as script. So that auth as script allows you to authenticate with that certificate. You just run it as a local admin on your Windows system, automatically logs you in, so you don't have to worry about importing the certificate, anything like that. Makes it easier. Microsoft's response was that this is kind of expected behavior, local admin protections, the certs kind of have to be available. I did talk with the ARC team and understand the design decision that they made. They have to have some way to authenticate up to the Entra ID tenant to authorize that machine and connect it with ARC. If they just gave it a hard-coded token, it's going to have the exact same problems as having a cert on here. At least with the managed identity, we can rotate certificates that you can control within Entra ID. If one of these certs is compromised, all you have to do is unenroll the ARC system and re-enroll it, and that cycles the cert, and then you're okay. So something to kind of keep in mind. So we got access to tokens that we generated. We've stolen some certificates. What do we do with them? You can authenticate with either AZ PowerShell or the AZ CLI with either of those options. And then once you have access to those, there's lots of tools out there. I'll plug Microburst here. There's PowerAzure. There's a ton of other tools that are out there that you can make use of once you've authenticated and can gather tokens for that. But really, that's kind of next steps as an attacker. You get your initial tokens or potentially your certificates, and then you can start using other tools to start pivoting, moving laterally, all that kind of stuff. So we'll wrap things up with kind of questions, conclusions here. I will say, in general, managed identities are much better than storing clear text credentials. Please make use of managed identities. They are actually a good technology to utilize in Azure. It's just they do kind of have their own flaws here and there, so be careful with how you use them and protect your resources. And if you want to have some persistent access as managed identity, go ahead and target ARC. So that QR code should be kind of my links and other stuff. You can find some of my stuff there. I guess I'll open it up for any questions here. Yep, question?
Yeah, is there anything unique about the ARC service, why they had to embed that cert locally? And is that ubiquitous across other resources, or is it just at the ARC?
So the question was why the ARC service needed to have that certificate locally. It's because when you've got systems that are out in, say, another cloud provider, they don't have access to that underlying Azure kind of framework or fabric, whatever you want to call it, that would allow them to talk out to the IMBS service internally there. So they had to deploy the certs that way, which I get it, but still gives us some options there. So the question was recommendations for ARC. Really make sure that you're protecting the endpoint itself that gets enrolled. So there's two different ways. There's protecting the subscription level resource, where you've got permissions to do the run command document, which is how the tool works. And then on the resource itself, restricting, say, RDP access, local admin access, anything like that. Pretty standard Windows protections. Yeah, so if anybody has other questions, I'll be hanging out here. Feel free to say hi. I do have microburst stickers. I'll leave some back behind here and happy to share them with other folks. Thank you, everyone.